Good afternoon. Today we're going to be talking about section 4.2, the mean value theorem. You may notice that I've started including in our modules supplemental videos, and those are videos that were published at the end of spring semester by another instructor, Bryce Christopherson, who's also teaching Calculus 1. He was teaching it for the normal pace, i.e. the entire semester, but he has published videos and he's welcomed me to include them in my curriculum. So if you find those videos helpful, go ahead and watch those, but I do encourage you to watch mine specifically because they will give you the information that's pertinent to the homework and the exams. And then if you need a little bit more explaining, feel free to watch his videos. And if you need more explaining still, send me an email and I'm happy to help you out. So let's get started. We start our discussion of the mean value theorem by talking about something called Rolle's theorem. Now, even though it's got a name, this one not nearly as important as the mean value theorem, but it gives us something to chew on while we introduce ourselves to this. So let f, our function, be continuous on a closed interval, that is, including a point A and including the point B and all the points in between, and differentiable on the open interval A to B, with f of A equals f of B. Then there is at least one point, if not more, C within A to B, such that f prime of C equals 0. Now, what does this mean? It's going to mean something very important, and it makes more sense when we look at a graph. But let's start by finding an interval I on which Rolle's theorem applies for f of x equals x cubed minus 7x squared plus 10x. Then we're going to find all the points C in I at which f prime of C equals 0. So I'm not going to make you take a moment and pause. You can just keep going with this video and we'll walk through it together. So I want you to note that when we factor f of x, we're left with x times x minus 2 times x minus 5. And f of x is a polynomial, so it's continuous and differentiable everywhere. And why are we asking these questions about continuity and differentiability? Well, Rolle's theorem requires continuity and differentiability on our interval. So if we don't have that, then we can't use Rolle's theorem. Now we're going to choose our interval. We can choose 0 because we have a 0 there, and we choose 5 just because that's going to give us the widest interval possible. Could we choose 0 and 2? Yes. 2 and 5? Yes. 0 and 5? Also yes. So we choose our interval because f of 0 equals f of 5 equals 0, and that makes it easy for us. We could also choose some sort of point, f of b equals f of d equals 72. We don't really care. All we care is that f of a equals f of b. Now, all we're left to do is finding the critical points, and that's as simple as taking the derivative. So to find the critical points, we find where the derivative equals 0. This is done by taking the first derivative. So of our function x cubed minus 7x squared plus 10x, our derivative is just using the power rule. We get 3x squared minus 14x plus 10. And we're interested in where this equals 0. We could factor and do all that stuff, or we could just go ahead and use the quadratic formula that we remember from our algebra class, which is x equals the opposite of b, so minus b, plus or minus the square root of b squared minus 4ac all over 2a. So when we plug our values into that, we get x equals 7 plus or minus square root 19 all over 3. You plug that into your calculator and you get 0.88 and 3.79. So now all we have left to do is check that that's in our original interval. Our original interval is 0 to 5. Luckily, 0.88 and 3.79 are both between 0 and 5. So we know that these 2 points, when we get our function, they're going to have a slope of 0, a flat tangent line. Their derivatives evaluated at these points equals 0. So now that we have something to chew on with Rolle's theorem, let's talk about the mean value theorem. And if you remember either of these two, this is the one that you need to remember. This is the big kahuna. This is the big idea that we're working with in this section. So let f be continuous on a closed interval a to b and differentiable on the open interval a to b. So now anytime we start a problem like this, we want to make sure that our function is continuous and differentiable on the interval a to b. Then, as long as these two facts hold, there is at least one point within the open interval a to b such that f of b minus f of a divided by b minus a equals f prime evaluated at that point C. So what does this look like in an example? Let's determine whether the function f of x equals 2x cubed minus 3x plus 1 satisfies the conditions of the mean value theorem on the interval -2 to 2. If so, find the points, maybe there's more than one, guaranteed to exist by the theorem. So our first step is our function continuous and differentiable on our interval? And because our function is a polynomial, polynomials are continuous and differentiable everywhere. So if it's everywhere, then it's certainly between -2 and 2. So we satisfy the two conditions we need from the mean value theorem. So then we calculate the following: f of b minus f of a divided by b minus a. And that's f of 2 minus f of -2 divided by 2 minus -2. Work all that out, and we end up with the value 5. So now our goal is to find points within -2 to +2 at which f prime of x equals 5. Well, we just did Rolle's theorem, which was f prime of x equals 0, so I'm pretty sure we can figure this one out too. Now we differentiate. So f prime of x is d dx of 2x cubed minus 3x plus 1. That equals 6x squared minus 3. We set f prime of x equal to 5 and we solve for x. We do all this and we end up with plus or minus 1.15. And that's as simple as it is. The mean value theorem guarantees that at the point plus 1.15 and minus 1.15, our function has a slope of +5. That's it from me.